Hello and welcome back to Cipheros. Today we're going to explore side limits. I don't know what there's to say, therefore just let's continue. So specifically, what does this notation mean? Check out this graph. On the left side we have a linear function, while on the right side we have a parabola. As you can just see, this function is not continuous, but there is a definition, a calculus 1 definition for this, but essentially this function has breaks. Therefore, we can leverage this approaching from both sides to see where is the function going. Therefore, this positive sign as superscript means that we are approaching rightwards. This means values a little bit greater than 1, okay? Not that positive 1, a little bit greater than 1. While this negative sign means values a little bit less than 1. We see from the right side, we are approaching, when we go to 1 from minus a little bit greater, we are going to 2. Similarly, the approach to 1 leftwards, we are approaching to 1. That is what essentially it means. In other words, f of x goes to L as x approaches to C with greater or less values. This is an expansion of the already known definition of limit we have. And the limit in general exists when these two values are the same. So we have three notation for limits, from less values, from greater values, and in general, when we don't specify the sign. If these two are equal, means that the limit in general exists. Let's go for another example. We have, in this case, a function with various segments. Try it out to calculate these limits. As you can see, when approaching to -6 rightwards, with values a little bit greater than -6, we go to 1. Okay, honestly, or as you can suppose, but anyways, this value obviously is different than 2, as on this pink line we have that it's a constant function, okay, which lies on 2. Now, time to verify if a limit exists by approaching to -2 on both sides. Supposedly it exists because it's like continue, but that point exactly may not exist, and therefore we must verify. So that's what we do, and just plug in this -2 on both sides on the limits and check out if this gives you the same exact result. Do you think that it does? Check it out by yourself. Continuing with the limit at the point, as you will perceive this function exactly on the parabola, and the constant part is not defined at 2 specifically, but there is a point that does it. Therefore, the limit in general exists. We are approaching to the same exact point from both sides, left and right. What I want to tell you is that the point may not exist exactly, or may be different. The limit can exist anyways. As you can see, f of 2 is equal to 2, but the limit exists and it's 4. Calculate these limits. Pause it on your notebook, on your tablets, etc., and let's go for it. So guys, this on the first part is not that complicated. Just approach to 2 leftwards, and that is all. You can see, because this function is continuous, okay, it's just a line. Just plug it in, the square root of 2 plus 2. That's all. On this case, on the second one, we have that we're approaching to 0 leftwards, but this doesn't make sense. And actually, this should be like that. Now I fix it, but here it is just not possible, or it is illogical, as on this function, the square root of x plus 2, this doesn't make sense. So limits actually make sense when talking about the domain of a function. However, on the right side, we can define it because it is 2. We are approaching to 2, as you can see on the graph actually. By the way, if the limit is infinity or negative infinity, it doesn't exist, but it's defined. These two things are very different. Now, checking out on the foreign limits, time to approach to this. First, try it out, but as you can see, you cannot just plug in because it will keep us 0. And do not think that because it keeps us 0, the values are going to be very high. It's not like that, but we approach for other techniques to simplify the function. Therefore, try it out. Well, this trinomial is factorable, therefore just we apply the definition of absolute value, as you can see over here. Simply simplify the function. And what about the side limits? If we approach to 3 from less values than 3, okay, a little bit, we approach to -5. Y approaches exactly to this value. But if we go to 3 from greater values, y goes to 5. Therefore, these limits are not equal, and we can say that the limit in general doesn't exist. Finally, observe this graph and calculate the limits, or also check out the veracity of these statements. The letter A says that if the limit of h of x as x approaches to 1 exists. Well, let's time to see the graph, and as we can understand, okay, from the left side we approach to 2, but from the right side we approach to 3. It doesn't matter if this point is defined, but this doesn't. Okay, we are not approaching to the same value, therefore it's false. Now, for the letter B, we have that the limit of h of x as x approaches to positive infinity is less than the limit of h of x as x goes to negative 2. Therefore, try it out. You can see that as x goes to negative 2, h of x goes to positive infinity because there is an asymptote. Similarly, when we go to positive infinity with always greater values, h of x goes to negative infinity. Therefore, it's true because positive infinity is greater than negative infinity. The letter C is very interesting because it is saying us that the limit of h of x as x goes to negative 5 doesn't exist. But let's check it out, the logic, as I told you on the previous. We are just considering the domain. Therefore, if we approach to negative 5 from the left side, it doesn't make sense because the function is not defined over there. Therefore, the only thing that remains is looking to the right side, and it is going to a certain point. Therefore, the limit actually exists, and this statement is false. Here are some additional exercises that I will solve on the next video. And here is the resolution from the most important exercise of the episode number 1. F of x is our cosa, we must do some translations, and the other function will be just like this. And if we calculate its limit, we see that we are overpassing the domain, therefore it's undefined. And that is all, guys. Seriously, thanks for watching, and thanks for supporting this channel. Follow us on Instagram and stay around with us for more maths and logic and programming content. Thanks for watching.